look at this one now, if we use the first method, direct substitution, the denominator is going to be over 0, which is undefined, indeterminate, and it does not exist. So we can't go through that method, that would be wrong. So instead of directly substituting, all we need to do is let us find the quadratic expressions for this one here. So if we do that, we get x plus 3, x minus 3, find the quadratics like this, and of course the denominator, and this can cancel out this can die with this. So this is the problem you can see that was causing the base to be 0, so we can just remove it like this. So we're left with x minus 2, and as you can see, we have actually done nothing bad. We did not irritate the function in any way. All we did was just manipulated the expression using algebra, correct, very correct, and got this. So now we can now substitute. So directly substitute. So x is now minus 3 minus 2, which is now minus 5. So the value of y is minus 5 as x tends towards minus 3. Very easy. So this one is actually very interesting, and it will open up your mind to exactly everything we've been doing so far. So if it wasn't clear before, it will be clear here now. So, and don't forget to subscribe if you haven't subscribed, turn on post notifications, and other relevant links will be in the description. So check out the previous videos. I'm going to put the link in the description, so make sure you guys check it out, and let me know on other areas that you want me to talk about, maybe on the past questions or anything like that. Use the comment section, let me know, and I'll make videos on them for you guys. So let's continue with this one now. So it says f of x is equal to the root of x plus 1, like this, minus 1 over x. So what is the limit as x tends to 0? So you can see clearly that you can never substitute here, because then the denominator will be equal to 0, and we don't want the denominator to be equal to 0, because that would be wrong, and the limit does not exist that way. So now all we need to do now is we need to solve it using another way. So if you can solve it, if you can find the answer to this already, you can go ahead, pause the video, try, but then when you are done, then you can unpause and see if you got the answer right. So this is a very common question you find in the past question, and so let's solve this one. Look at this. So we have, please pay attention to this, because this is very important. If you find something like this, it might be at the denominator, it might be at the numerator, it doesn't really matter. So if you find an expression like this, all you need to do is multiply this expression, the numerator and the denominator, by the conjugate of the numerator. Multiply the whole thing by the conjugate of the numerator. So this is x plus 1 plus 1, right, over the same thing, x plus 1 plus 1. If you find an expression like this, you can memorize it. Anytime you find something plus something, you can always multiply the whole thing, the numerator and the denominator, by its conjugate. So what I did, see, x plus 1, the square root like this, plus, once you put plus, that is the conjugate. That's why I put them in different color. Once you put plus here, it becomes the conjugate. So if you have, let's say the denominator was x plus 1. So if I want to change this expression now, and I multiply by the conjugate of the numerator and denominator like this, it will be x minus 1. That's the conjugate, the opposite. So just flip the sign, so multiply all through, like multiply the up and the numerator and denominator by x minus 1, x minus 1, like this. So but in this case, we have the expression up here, we have something like this root here minus this one here, so we can multiply the numerator and the denominator by the conjugate of the numerator, like this. So just change the sign and multiply that way. It is very correct. Multiply this by this and multiply this by this. So if you do that, root like this, root x plus 1 multiplied by root x plus 1 is the same thing. So the root cancels the root, so that will be x plus 1, like this. This was very simple. All I did was multiply this by this. So if you multiply this by this, because of the root will cancel out each other, so that will be x plus 1, and then multiply this again by this, so that will be plus root x plus 1, and then multiply this by this, that will be minus root x plus 1 following, and then multiply this again by this, so that is this by this, which is minus 1. So this dies with this, and we have this one again with this one, so this dies with this, so we have just x as the numerator, right? So the numerator becomes x. So what about here? So if I multiply x by everything here, I would get x multiplied by everything. So you see the same thing, like root x plus 1 plus 1, like this, everything here. So the denominator will become everything here. So if you don't know how I got this x, just watch the video again and again and you get it. So now this is the final result. All we need to do is just cancel out x. So this x dies with this x, so this dies with this, and then we are just left with 1 over, right? So we are just left with like this 1 over everything here. So now this is now the new expression that we work with. Now all we need to do is just direct substitute. So if you put 0 inside here, this becomes the square root of 1, and square root of 1 is still 1. So the square root of 1 is still 1, and 1 plus 1 is 2, right? 1 plus 1 is 2. So the answer that we're looking for, as x tends towards 0, f of x will be equal to 1 over 2. So that is the value of y. Very correct. So as x tends towards 0, the value of y is a half, just 1 over 2, 0.5. So guys, that's it for this video. Keep debugging that maths, and I'll see you guys in the next one.